Morning, everyone. Good morning, morning. How are you guys doing today? Good. I see Jack remembered his stuff from last class. Yay. Any question before we start? Quiz now. I have so many things to grade, so I'm skipping the quiz for now. Plus, I have to write a research paper before 16th. So I'm really busy. That is my plan. AI. So any question, comments, concern? Anything before we start? Nothing? So I believe the last thing we did in our class last week was rationalization. So do you remember when you have only one denominator, how do you rationalize? By what? The entire denominator for I? The left page. So 4 is a real number. Do you have any problem with real number? So you don't need to worry about 4. What is our problem here? I. So we only multiply by I. So multiply numerator and denominator by I. Since we multiplied, it's 2. So what do we have now in the denominator? 4i times I is 4i squared. But what is I squared? So what is 4 times -1? -4. And now you're happy because -4 is a real number. We don't have to worry about that. Well, it's too dark. I mean, too light. I should make more darker. Now the numerator. Do you remember what do you do in the numerator? Distribute. So 5 times I gives us 5i. And 3i times I gives us -3, but we're going to do in next step. So it's 3i squared, but again, I squared is a problem. It's not problem. I squared is -1, the real number. So, like Amar said, it's 5i minus 3. Are we done? What is our next step? What do we have to do? Separate them. Good job. So we have 5i minus 4 and then -3 over -4. At least here we have double negative, so it will turn into positive. So we have 5 minus 4, 5i minus 4 plus 3 over 4. Are we done? Since I'm asking, are you done? That means we are not done, right? That's why I'm asking you. So what is our last step? What's wrong with this? No. No. See, Karen is right. The order is wrong. When you write complex number, you have to write the real number first and then your imaginary number. Imaginary has to come later. Your real number has to come first. But here we have I first and 3/4 later. So it doesn't make sense. You have to switch them. 3/4 minus 5 over 4i or 5i over 4. And now it's completely done because we followed the method A and then BI. Do you guys remember doing it before the break? Good, if you remember it. And if you're not, no problem. We just refresh your memory. Any question on this? Wonderful. Now, how many terms we have in this example on the right side? 2 terms. So for 2 terms, can you apply the same method, multiplying by I? No, it doesn't solve our problem. Conjugate. So what's a conjugate? Conjugate of the numerator or denominator? Denominator. So what's the conjugate of the denominator? 7 plus 4. I. And now if you're like me, you're going to do numerator and denominator separately. So the denominator, why do we love conjugates? Because we get perfect squares. 4 square I square. We square each term on the denominator. 7 square, 4 square, I square. And the sign between them is always negative, always. Regardless of what you have on the denominator, we don't care. When you multiply the conjugate, it's always difference of perfect squares. So here we have again -1 problem. So negative and negative turn into positive. So we get 49 plus the 16. And now do you know what is 49 plus 16? 55? 65, yeah. You can do this mentally easily. For example, we have 49, bring 1 from 16 and make it 50. So we have 50 and we have 15. So 50 and 15. 50 plus 10 is 60. And we have extra 5, so it's 65. That's the trick to do it mentally. So you've done a denominator and you're happy there is no more I. Now in the numerator, there are 2 choices you have. You FOIL directly if you're good at foiling, but if you're bad at foiling, no problem. You're going to do it in 2 steps. FOIL. When you distribute twice, we call them FOIL. So you take 5 and you multiply the entire 7 and 4i. And then you take your 3i and you multiply the entire 7 plus 4i. If you cannot do it together everything, then separate them. But if you can do everything together, no problem. Do it everything together. So here you don't have to do FOIL, you're going to just distribute. What is 7 times 5? 35. And then plus 20i. Then you're going to distribute the next one. Plus 21i plus 12i square. And again, we see another I square, so it turns into -1. Also, what do you observe in the middle? Like terms. So 35 plus 41i, and you're subtracting the 12 because 12 times -1. So these 2 are like terms. So we get 23 plus 41i over 65. Are we done? What is our last line? 23 over 65. And now we are finally done. So this is what we do when we try to divide by I. We don't know how to divide by I, so instead of dividing, we do rationalizing. And now since we are doing I, so instead of going to chapter 10.6, I'm going to start 10.7, where we are going to learn more about I, the imaginary number, complex number. But before I do that, any question, comments, concern, anything so far? Okay. So this week we are going to have a normal class, Tuesday, Thursday. But next week we have 14. 14 is a Tuesday, but we are not going to meet. Because next Tuesday is a Monday schedule. Oh. So you're going to go to Monday classes. Instead of come to our class, you're going to follow a Monday schedule. So next week, Monday is Monday. Also Tuesday is a Monday. Okay. So we're going to have 2 Mondays next week, and there will be no Tuesday. Hmm? You don't have any class on Monday? Oh yeah. Monday we have off, and Tuesday is a Monday schedule. Oh yeah, thank you for reminding me. I totally forgot. So yeah. Monday there is no school. We are going to have a vacation, small mini vacation for 1 day. Oh no, not 1 day. Saturday, Sunday, Monday for 3 days, small vacation. And Friday, if you don't have a class Friday, then yes, 4 days. And then you're going to go to Monday classes. Okay. Unfortunately, I do have my Monday class. So yeah. Okay, so we already know that square root of -1 is I, but when do we need them? For example, if you try to solve x squared plus 1, we know x squared is a parabola. Do you know that x squared is a parabola? We do know, right? Yeah. Because I told you the shape. Okay, so x squared plus 1 is a parabola. It's shifted 1 unit up from the origin. So this is 1. This is x squared plus 1. Now, when you try to solve it, you cannot solve it because it's not touching the x-axis. Solving means what's the x-intercept, or when you cross the x-axis. So since we cannot cross the x-axis, there is no way we can solve for x. So if we try to solve it algebraically, we subtract 1 from both sides, and we end up getting x squared equals -1. And then we think, what number when you square turn into -1? In real life, it's not possible. So when you take the square root, you get x equals square root of -1, but square root of -1 doesn't exist. It doesn't exist in the real world, but I don't know why mathematicians invented the imaginary world. They said, well, this does exist in the imaginary world. We call them I, 1I. Instead of giving them only 1, we call them 1I. So square root of -1 is I, and anytime you multiply any 2 imaginary numbers, they turn into real number. So even the square root of -1 is I, but I squared is -1, real number -1. So if you have any type of negative number under the radical, it doesn't matter what number you have, any type of radical number, we're supposed to split them into 2 pieces. For example, if you have -a under the radical, we write -1 and then +a. Why do you do that? Because here, a doesn't give us any problem. A is real. The problem is the negative sign. Negative under the radical is not real. So it's split into 2 pieces. One is real, one is not real. And then we convert the not real portion into I. And the real portion, if it's a perfect square, we get a smaller number. If it's not a perfect square, we just leave it alone. Okay? For example, here, square root of -16. 16 is a real number, but negative under the square root is not real. So we have to split that into 2 pieces. Square root of -1 and square root of the real number, +16. So this gives us imaginary number I. And what is square root of 16? 4. But like I said before, we're supposed to have the real first and then the imaginary. So we have to switch the position. Instead of I4, we should write 4I. Question? Okay, B. What do you think about B? Question number 1. Can you multiply the negative from the outside with negative in the inside? Can you multiply them? Can you? Why not? So why we cannot multiply the inside the radical? We cannot. Because of the order of operation. Order of operation says do parentheses back and then exponent. So square root is an exponent. It's 1/2 exponent. So whatever you have inside, you have to work with that first, and then you can do the multiplication. So you cannot multiply here. It's not possible. Because M is not first, exponent is first. So we keep our negative sign, and then we split our negative 9 into 2 pieces. -1 and +9. So what do we have? What do we get? Negative, and what is square root of -1? What do we get from here, guys? I. And how about square root of 9? 3. So what is our final answer? -3I. The same thing, we just switch the orders. Question? Not yet. Okay, you guys try this too. One is reducible and one is not reducible. So try them. Let me take your attendance.
Yo, everybody's got something about the whole little black. That's what I'm saying. That's what I'm doing.
Today is 10. 10 what? 10-7. Krish, not here yet. Jack, here. Eliza, here. Karen, here. Alana, here. Maria, not here. Daisy, here. Justin, here. Parchung, no. Alera, here. Hiba, here. Shahida, here. Louisville, here. Marlene, Pyro, sleeping. Jiajun, Valerie, Yeri, Mar, Amen. Nihan, Ingrid, Sophia, Antonella, Ronald, Gur, Ebony, Zohail, and Terrence. Today Terrence is missing. Ready?
No.
Real. Valerie, would you like to help me with C? Hmm? Hmm? Okay. So -1, +7, that gives us I square root of 7. So for my MATLAB, it wants you to write the I first before your radical. Because in real life, if you do that, well, we assume I is after the square root. But when you type it out, sometimes it same as this one, okay? It gets inside the radical. So MyMATLAB confuse your input. So it doesn't want you to write I later. It wants you to write I first. So this is for MyMATLAB. But in real life on the paper, you can write this, no problem. This is for paper. If you write on the paper, you can write I after the radical. But for MyMATLAB, you should write I before your radical. Lorisbel, would you like to help me with D? Mm-hmm. Mm-hmm. So 18 is under the radical, right? Can you split 18 into two pieces? One is perfect square and one is not. 9 and 2. 30 square root of 9. 3. So we get negative I3 and radical 2. The order looks weird, right? So for MyMATLAB, it wants you to write negative 3I square root of 2. However, for paper, like if you write on the paper on the exam, you can write negative 3 square root of 2 and then I. Either one of them is fine. This. So sometimes the number we have inside the radical, we call them radicand. The radicand is not reducible, like 7 here, but sometimes the radicand is reducible, like 18 here. So anytime you can reduce anything, you have to reduce that. Okay? Great. So we actually know how to multiply because in division, we already multiplied, right? So you can skip the multiplication part. But let me just go over a few of them. For example, here, negative 3i minus negative 3i times negative 9i. How do you think we should multiply? So we multiply the numbers with the numbers, the real numbers. So we have negative 3 times negative 9. The real number, you multiply them. And you multiply I with the I. So we get positive 27I squared. But anytime you see I squared, you cannot leave it alone. What is I squared? Negative 1. So if you multiply 27 times negative 1, what do we get? Negative 27. What are you doing, Omar? Okay, the next question. I should put a note here. 42. So previously we did radical multiplication, and well, multiplication is possible if you have the same radical. When you have the same radical symbol, we are allowed to multiply the inside. But we are allowed to multiply the inside only if the radicands are positive. draw. Okay, so for that this happens, no problem. Let me see, where were we? Which slide? Oh, this, so let me make it bigger. Yeah, because it's one page. You'll see. Here I wanted to write something. So we can multiply. It doesn't work so well. Okay, let me erase. Can I erase? No, I have to go back. The updated Word file, so it's kind of cool now. Okay, multiply, I'm seeing a P. Come on. We can multiply radicands okay, I'm wasting my time. But anyway, let me write them only if they are positive. Okay, so this is what I wanted to write. Now let me go back to our two sides. We can multiply radicands. This should be D, not T. We can multiply radicands. Okay, I'm not in that mode. Come on. So let's go back. Let me save it. Let me reopen it. Give me 1 second. I'm trying to reopen it. Cairo, finally you are oh. Okay, we can multiply radicands only if they're positive. Here our radicands are not positive. One is -2, one is -14. So we cannot multiply them directly. We can multiply them if you take out the negative first. So square root of -2 times square root of -14, not multiplicable unless you bring your -1 out. So square root of -1, 2, square root of -1, 14. And we know this gives us I, also this gives us I. So once you pull your I out inside the radicand, now see 2 and 14, they are positive. So we are allowed to multiply them because they are positive. So when you multiply, we get square root of 2 times 14. 28. So we have I times I square and 28. So let's do it here. What is I square? -1. And the 28. Can you split 28 into 2 pieces? One is perfect square and one is not. 7 and 4. So we get -1 times the 2 times the square root of 7. So what is our final answer? Square root of 7. This is one way of doing it. But this is not the only way of doing it. It's only one way. There is another way of doing it. For example, here. When you have your I, you have square root of 2 and square root of 14. Break down your 14. You have square root of 2 and square root of 7. So you have I square, square root of 2 square, and square root of 7. I square is -1. Square root of 2 square is 2. And this is not breakable or reducible. So you keep it. And that's the final answer. This is another way of doing it. But it definitely cannot multiply the radicand in the first step, like here. -2 times -14, it cannot do that because they are not positive. Only in multiplication, you have to have the radicand positive. However, for division, it doesn't matter. Think about the division. How can you do the division? There are so many ways of doing it. Any volunteer? Besides these guys. From the right side. Any volunteer from the right side? Daisy, what do you think? There are so many ways of doing it. What do you think? Even if it's wrong, no problem. Take out the negative, good. So -1, positive 90, and -1, positive 2. We can cancel them actually before even converting them into I, because they're the exact same two things. And then what did you do? So you wrote a big radical. So what two numbers? 9 and 5. And what is square root of 9? And we don't know what is square root of 5. Let me put a little bit space, otherwise people think it's cubic root. 3. Perfect. So this is one way of doing it. Anybody else has any other idea? Of course, correct. Can you think of any other method? Jeff. You can do that. They're going to get canceled anyway. So from here, you get straight square root of 45. Any other method? Let me show you another method. You split them into two pieces, not two pieces, three pieces. -1, +2, and +45. And then you have -1, +2. So they cancel out, and you get 45, which is 3, 5. So at the end, you're going to get 45 anyway. No matter what you do, you're going to have 45. So before you get to the 45, there are many ways of approaching the question. Okay, let's see what comes next. Complex number. So imaginary numbers are complex number. We call them complex number usually when they have two parts, visible two parts. For example, here, the example we did before, 2 plus 3i. We see 2 and we see 3i, so they both are visible, so you call them complex number. However, even if you have only 3i, still it's a complex number, but usually you don't call them complex, you call them imaginary number because of the I. Huh? So complex number has two parts, real and imaginary. And you're always supposed to write the real first and then your imaginary part. And then you can ignore all of this. Blah, 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 blah. Blah, 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 blah. To add and subtract, we already know because we did the division. In division, we did addition, subtraction, and multiplication, all these things. So here is one example, a separate example where you're subtracting two imaginary numbers or two complex numbers. Distribute. Since you're subtracting, so your sign will change for the second complex number. The first one doesn't have any problem, 8 minus 9i straight. But when you distribute a negative sign, you get negative 6 plus the 5i. Combine like terms. 2 minus 4i. And that's our final answer. 8 minus 6 is 2, minus 9 plus 5 is minus 4, and we keep our I. I is just like the variable x. So here, difference between I and x is that x could be anything, but I cannot be anything. I has to be imaginary number. That's the difference between I and x, but they work same way. There is another example. Negative 6 plus negative 3 minus 7i.
Six. And five is next time. Minus 3, minus 7.
Perfect.
3 minus.
So we have only two real number here. So only two real like terms. We get 3 from here, and we have a single 7i. So there is no problem with the 7i. See, sometimes we have two parts, so we can combine twice. But sometimes we have only one part, so you're allowed to combine only one portion. And whatever we don't have a partner with, they just bring that down. An interesting one. Think about it. I love this question, so I'm going to put this in the exam. Looks bad, but actually it's not bad. That's true. Okay, so Cairo and Krish are here. I marked you guys absent before. Yeah, let's go. It's time to go. I wish. Any idea? So -1, positive 36. Here we have 2, -1, positive 36. Oh, 49. And what is square root of 100? You don't have to break it down. And now what do we have? I and 6. And then here 2 I and now what do you write? 6i plus 14i. 10 doesn't have any I.
And then it becomes -10 in the correct order.
-10 plus 20i. So this side, are they too fast to you guys? Are they too fast for you? For the right side of the class, the left side, are they too fast? Or you guys are on the same track? On the same level? So you're not behind, right? Anytime you don't understand any step, please ask me. Because otherwise, how do I know like what is confusing? For me, nothing was confusing here. So that's why I can understand your point of view. So anytime you don't understand anything, please help me to understand what could be a confusing part here. Okay, any question? Comments? Okay, multiplying I'm going to skip because you already did so many multiplying when you did division. So let me know once you are done with the left page. Are you guys done with the left page? Okay. So in multiplication, we just multiply using FOIL. Oh, let me do two multiplication. The right page. We have 3 plus 2i whole thing square. What does that mean? What you are multiplying here? Really? When you are adding or subtracting terms, it cannot distribute the power. Distribution power comes only for multiplication or division. The square tells you to multiply the same thing twice. You can do the formula a square plus 2ab plus b square. Or you can do foiling here and then you distribute. So let me do foiling this time, okay, instead of distribution. When you foil, you take the first one and you multiply both of them in the second one. So 3 times 3 gives us 9. And then 3 times 2i gives us 6i. Then you go other way around. You take the second term and you multiply both of them on the second factor. So what do you get when you multiply the green arrows?
Plus 4i.
Good. But what is I square? As a result, what do you get from? -4. So we have 9 minus 4, which is, and in the middle we have 6i plus 6i, that gives us 12i. So you're using foiling method and then you combine like terms. Every time you see I square, it becomes real number, -1. As a result, the term changed its sign from positive to negative or negative to positive. Clear? For the last multiplication, what do you observe? What type of factors we have here? The last one. What type of factors they are? What do you call them? Conjugate. So we get perfect square. So these are conjugate pair. And we love conjugate because we don't have to do foiling. Anytime you multiply any two conjugate, the result is difference of perfect squares. So you take your first term, you square, and you always subtract. You take your second term and you square. So it's 2 square, I square. First term square minus second term square. But second term has 2 terms, two elements. So you have to multiply each element by your square, not multiply. You have to put the square on each element. Yes, you can do foiling, but you don't have to. What is square root of 5 square? They cancel out, so you get 5. And I square is -1, so you get -1 here. 5 plus 4. So it's the real number 9.
Yeah.
So in real life, anytime you multiply two imaginary numbers, they become real. Anytime you multiply two conjugate pairs, they become real. Okay? Any question? So we learned how to add, subtract, multiply, divide imaginary numbers. Another last concept, how do you reduce the power on I? For example, when you have I squared, we never leave it alone. We always write -1. So anytime you see I with any other power besides 1, you must reduce it down. And when you reduce it down, you get 4 choices. Either your answer will be -I or +I, or your answer will be -1 and +1. Anytime you have any power on I besides 1, you have to reduce down to one of these. The question is, when do you get what number as the final answer? So you're going to learn that now. Let's see a few examples. I cube, we know it's I square and I, right? So we know I square is -1. So we have -1 times I, that gives us -I. See the example here? The final answer here? -I. Not only even an odd, there are more to it. So this is I square and I square. So -1 and -1 turns into +1, which is this one. Now I to the 5, it's I to the 4 and I, right? 4 and 1 gives us 5. What is I to the 4 from before? No, 4. 1, it's 1 times I, which is the +I, which is this one. See, different power gives us different outcome.
Wow.
Even in odd, they have more to it. Not only even an odd. So we have I to the 4. No, let's see I to the 5. We have I to the 5 and I. Right? We know from before I to the 5 is I. So it's I times I, which is I square, but I square is -1. So we have this one as our answer. So see, we have two odd powers, 3 and 5, but the outcomes are different. One of them give us -I, the other one give us +I. We have two even numbers, 4 and 6, but still we have two outcomes. One of them gives us +1, the other one gives us -1. But at least what do you observe here? When you have one even power, what the outcome should be? Either 1 or -1. Definitely. Anytime you have any even power, you have the number outcome. Either it will be 1 or it will be -1. But your answer will be a number. When you have odd powers, your answer has to have an I in it. Either it will be +I or it will be -I. Okay? Now, when you have odd power, always split into two pieces. One is the highest even power, and the other one is I. For example, I cube is 2 power and 1 power. I5 is 4 power and 1 power. So split them. Anytime you have odd powers, split into two pieces. One is I and one is everything else. So for 5, it's 4 and 1. If I give you 55, what two pieces you're going to have? I and what? If it was 55, then one of them is I, and what will be the power for the other one? 54.
Wow.
So anytime you have any odd number, split into two pieces. One is I, and one is the rest. So for 55, it's 54. For only 5, it's only 4. Okay?
So we're gonna keep reducing it?
For 7, what will be 7? What two numbers? 6 and I to the 6 and I to the 1. Why do we care? Because when you have even power, we know the answer, either 1 or -1. So we are going to decide based on the even power, which one will be our one, which one will be our answer, +1 or -1. So you have to figure that out. There are so many ways people do so many things, but my favorite one is observe either 2 power or the 4th power. For example, 4, can you divide 4 by 4? Yes. So when you can divide 4 by 4, the answer will be +1. Can you divide 6 by 4 evenly? If you cannot divide, the answer will be -1. Okay?
6.6.
What did you say? Okay, now instead of 7, I to the 7, which number you're going to use? No, I said use one I and the rest should be the other one. I to the 6 and 1. But in the exam, will you know?
I to the 4th is 1, and then you just take I to the 3rd.
What is I to the 3rd?
Like -I.
See, you memorize that.
Yeah.
But people are learning it for the first time. That's what I said. There's so many ways you can do them. And if you already know all this stuff, forget about my method, okay? If you already know how to do this, use your method, no problem. But what I found is easier is this one. Split into 2 pieces and divide the power by 4. Can you divide 6 by 4? We cannot. So answer will be negative because we could not divide negative and we have our I down.
That's a cool trick.
How about 8? Can you divide 8 by 4?
Yeah, so it'll be +1.
+1. So if you can divide whatever power you have, if it's divisible by 4, the answer is +1. So even. If you have even power not divisible by 4, then the answer is -1. So you only have to remember one rule. When you even power, what happens? When you add power, split fast and then use the even rule. Okay? Let's try one more here. Let's say we have I to the, like this one we did before, 54. No, not 54, sorry, 55. 55, is it odd or even? Odd. So you're going to split into 2 pieces. One is I and one is I to the 54. Now, can you divide 54 by 4? No. Since you cannot divide, what will be our answer? Negative, and we bring down our I. -1, okay? So let me do step by step, no problem. Since we could not divide, so this is -1. And we have our I down, so the answer is -I. So split the odd power into 2 pieces. One is odd and one is even. Now divide the even by 4. If it's divisible, the answer will be 1. If it's not divisible, the answer will be -1. So either 1 times I or -1 times I. Is it clear a little bit? So there are other methods, okay? I have 4 methods here. All of them are valid. And I will post the lecture notes so you can just read them. Let's do some fun example. 22, is it odd or even? So can you divide 22 by 4? Can we? No. So what's the answer?
Oh, it's positive.
22 divided by 4 is not possible. So answer is -1. We cannot divide, the answer is -1. If you can divide, then say it's positive 1. How about 20? If I ask you I to the 20, it's 1 because we can divide 20 by 4. It's possible, so it's positive 1. How about 23? I to the 23. 23, is it odd or even? Odd. So you have to split into I, and what's the other power? 22. And 22 is not divisible by 4. So what do you get? Negative 1 times I. So it's positive I, not positive I, Omar. It's negative I. If you have odd power split into 2 pieces, because you want to see the even, you remember the rules for even. If the even number is divisible by 4, the answer is 1. 1 means yes. If answer is not divisible by 4, the answer is negative 1. Negative 1 means no. Negative, no.
R67.
Hmm?
R67.
I-67? Sure. I to the 67. 67, odd or even? Odd. So you're going to split into 2 pieces. Amar, go ahead. What 2 pieces you have? 66 and 1. Now, can you divide 66 by 4 evenly?
No.
No, because we can divide 60 by evenly and then 64, but not 66. So what's the answer if we cannot divide? We cannot divide, so negative 1 I, which is negative I. Now, interesting one. What if we have negative power? Good job. It's the exponent rules. X to the negative n is 1 over x to the positive n. Exponent rule. Did I tell you that I'm going to put the same exponent rule in the second exam? Yeah. So make sure you review them every day, or at least every week. So we get 1 over I to the positive 25. And now 25, is it odd or even? That means you have to split. Which 2 pieces? 24 and 1. Now 24, can you divide 24 by 4? Yes. So what do you get? 1 and I. So you're 1 over I. You always have to. So how do you rationalize? We multiply by I, numerator and denominator. So we get I over I square. But I square is negative 1. So you get negative I. You cannot have negative power. You cannot have anything on the denominator, any I on the denominator. Anytime you have I with any power more than 1 or I is on the denominator, you have to reduce. Any question? Okay, then few more examples. Let me put all of them together. So I to the 29. And then I to the 28 plus I to the 35. And then 60, 70. I to the 60. I to the 70. 37, 70, 51, 84. We only have 70. Okay, never mind. 37, 70, 51. I to the 37, 70, 51. What else we have? 84. So minus, plus, minus. Okay, so 1, 2, 3, 4, 5. 5 examples. Go ahead, guys. Try them. 5 examples. Which is 84. Reduce the power of I.
Is it easier if you add the powers or do it separate?
You cannot add the powers. For example, exponent rules. If you have x to the m minus x to the n, can you do anything with the powers? For example, if you have x cubed and x squared, can you combine the powers? Exactly. But what's the exponent rule when you have two powers together? If you have x to the m and x to the n, it's x to the m n. So see, so many rules. And this will be in the exam. In the exam, we are going to have addition, subtraction, multiplication inside your division. And then you're going to reduce the power. So try them.
He's not saying it's not a big guy. Look at the problem in life. You're giving two. We'll take two. It is one. Save one for tomorrow. I don't have the pencil.
Once. 98. The highest score. Multiply good. 9, that's 6. I don't think it's Because 36, you can see it's like 59.
Then what do you do?
68, 19, can you divide 68 by 4? So it's positive, right? It's like 1 time, it's math. If you have x squared minus 4, can you add the powers? Yes. The difference is X is to benefit, but I expect
I'm not gonna.
You said it bigger height, but that's divided by.
for X,
Yo, but I'm.
go up to the. But I.
Don't even worry about it. I
carried the big day, I carried your face.
On this day to day.
It's shy, definitely. Shake me, shake them.
You don't have to worry about that too much. So like. He's so sweet. Oh, my God, I told you that explain it. Jack, yeah, it's like, yeah, bro, I have to customize. Word, bro, 25. Gee, that's their type one.
It's nothing to like one.
Yeah, this is you pick fruit. I teach. I got to sit down in the classroom. I still like so I
Haven't checked my, wait, haven't checked the, Right, I got 3 old ladies.
You find.
I-28 is what? And then this breaks it down.
We're both loud.
I go. I think I was at first, but I got.
Okay.
I know.
Then I can laugh. I know what I can get.
Yo, this was first.
I mean,
Say what do you do?
I got first. Yeah, I got double.
I don't know if there's not a piece like this.
Because they can let in the image.
I don't know. Oh, yeah. It starts in an hour, but it'll work. Yeah, I think it is.
I'll be alright. I know.
Well, I can just keep because I'm going first.
Yeah, if you're okay with both.
Then I will first again. Forget about it.
So what do you pick first? Oh, but I really want, bro. If you're.
Oh, that has?
Yes, bro. Oh, there's an eye on you.
I'm not gonna play it.
Why? Okay.
That's me.
Yes, I can. Yes, I can play too.
Jay Berry. How do I change the name?
I'm good.
Under beast. Look. I mean, I did mine. I'm city walk in my abbreviation.
You're 2,000.
Oh, when your dad
You cannot divide by negative one.
35 divided by 44. Where the hell is my phone going?
And between them,
You have 20. So more. Rebound for where's the EDP? EDP? ADP. ADP. You know what I'm talking about? ADP, what is it? That's not just about a cash out. Wait, okay. Well, actually, put my one.
Yo, man, shut up about this damn guy. I'm trying to ask a question. Just make another one. Yo, is it not this?
Hey, guys, I have 12 years.
Oh, you mean that? I mean that. Now kick him out there. I got point on it.
Bro, listen. I thought you were going to go Google. 1.2.
You don't know what's deep. What team you play? Oh, it's average. No, Anthony Edwards. That's Anthony Edwards. I think my shit. I'm saying, boy. Yeah. Lakers. Still on the Lakers?
Yeah. 80's on the map. Yeah, he's so
I'm watching. I stopped playing. I'm about to win this guy. Who's Stephen Curry playing? The Cavaliers are out of here, but he went on shit. Yeah.
Yeah, the last one. Last one, just the last one. What I got.
I 35. Okay, I got a question.
Oh, yo, just change it. You got one class with the best day all day, every day. Oh, hell no.
That's all.
Jeffrey, I'm 60 plus with you.
Yo, look, he's at him. I won't see that. Wait till we see how it's going to go. Like, oh, I'm going to win. What's going to I'm about to go sit with Kyrie. Yeah, I'm stopping.
Okay, go see what kind of. Why you saw another grown ass man to this?
Now wait till that. I'm trying to sit down.
I'm 11, she's 20, so.
Because he's smarter than me. I'm just. What's after? What's after? Thank you. That's good. What's after?
32.
I better than I think there was. Yo, where's DTP?
Bring it down. Yeah, that's funny. Shut up.
You keep talking, but
You're
he's worse than the anthropology professor, bro. You don't know. How long you doing? Like just no.
So I write down negative odds. No, brother.
My phone, so it's probably one. Then I do two. One times I. Alright, one times I, one times I. One times I, one times I. What is one times S?
Answer is 1 minus R.
What is one times S? Good. And what is one times I? That's it.
Wait, I'm saying science doesn't relate.
How do you answer that? Exactly. Why does it two? No, how does one get two? One question they got two parameters and ask you. Because you double plus two. So, already two things.
Oh, don't get it.
Or probably.
Bro, you got a question. No, it's just our
How many?
Three, I think. There's three into the three, bro.
So 7 actually pairs will not.
If it, so the best is for.
Guys,
Oh, yeah.
only I.
So I actually have to. Well, it tells you, like when Aaron Rodgers. Why you feel bad? It's everything. Oh, you gotta hold to that. I got rid You can actually make them. Yo, look, you got
Already we could start, we could start, week 5. How do we do that?
Yo, everything I love is driving.
These are, these are not.
What do you mean? His fish, he cooked.
Yeah, but he was just.
So exponent rules, you have two parts together, you multiply them. So we get I to the 3 times 2, 6, 3 times 3, 9. 69. Is 69 odd or even? Odd. That means you have to split into two pieces. What is 1 of the power? 68. Now 68, can you divide by 4?
Yep.
Yes. So this will give you what? 1, and we have our I, so the answer is 1I. For the next one, 29, is it odd or even? So you have to split. Let me do it here. Come on. Oh, let me restart. I hate this. Yeah. So we have 29. I to the 28 and I. Can we divide 28 by 4? Yes. So what do we get? 1. And we have our I, so it's 1 times I, which is I. Now for the next one, many people combine the power. Almost 99% of you combine the power. You cannot combine the power because if I give you I to the x to the 2 and x to the 3, can you combine 2 and 3? Then how can you combine the power for the I? I and x, they're same. The difference is x could be anything, but I is specifically -1 under the square root. Okay, but all the rules are same. All the exponent rules are same. You cannot add or subtract the powers if you're adding or subtracting the bases. That means you have to do it individually. So I to the 28, Can you divide 28 by 4? We can, right? So since we can, the answer is positive 1. We don't have to do anything. It's simple positive 1. Now for 35, is 35 odd or even? Odd. So you have to split. I to the what?
32.
34. 34 and 1. Now 34. Can you divide 34 by 4 evenly? No, we can divide 36, but not 4. So this gives us negative 1. So negative 1 times I, and you have positive 1. You cannot cancel because what Panda says, multiplication comes first. Pandas. So you have to multiply 1 minus I, and you cannot combine them because they're not like terms. So leave them alone. It's 1 minus I. Next one is same thing. We have 2 even numbers. Can you divide 60 by 4? Can you divide 60 by 4? We can. 4 times 15 is 64. So we can. Since we can, the answer is positive 1. So this gives us positive 1 minus. Now 70. Can you divide 70 by 4? No. That means the answer is negative 1. So this gives us negative 1. So we have double negative. So it's 1 plus 1. So it's 2, not 0. It's 2. So this negative is from the question. The last one. This is even, so you don't have to do any math. How about this one, 37? What 2 numbers we write? 36 and I. How about 51? 50 and 1. So these two to split, and these two we can do directly. So we have a minus. Can you divide 70 by 4? No. So answer is negative 1. Can we divide 84 by 4? Can we? Yes. So this answer is positive 1. We don't have to write positive. It's 1. So let me change the color to red. So in the middle we have this. Okay. Now here, 36. Can we divide 36 by 4? Yes, so this gives us positive 1. For 50, can you divide 50 by 4? No. So this gives us negative 1. Now let's write down everything else. We have an I here, this one, minus. Minus and minus turn into plus. So this is plus 1. And then here we have plus. We bring down our I. And we bring down minus 1. Plus 1 minus 1 cancel out. We have I minus I. They also cancel out.
If you're gonna be doing like I to why not just do I 37?
Because 37 is odd number. And the rule I taught you is only for even number. If the number is divisible by 4, the answer is 1. If it's not divisible by 4, the answer is -1. But the power has to be even. That's why for odd, you have to split into even, and then you apply the power, apply the rule on the even. So the answer is 0, not 2 actually. Because 70 gives you -1. The double negative turns into +1. 84 gives you -1, so you keep it -1. So -1 and +1, they cancel out. Now for 51, 50 gives you, let me change the color. 50 gives you -1. But 36 gives you +1. So you have positive I and negative I, they also cancel out. So what do you have? Everything cancel out. Any question? If this is hard for you, do 4 of them individually and then combine the results. I'll give you all 4 together in one question. This will be in the exam. And quiz, I'm not going to give you any quiz at least till next week. I have to do my research paper next week, before next week. Yeah.
Okay.
So with this, we are done at 10.7. So your homework. You are going to have a homework on 10.7 next week, Tuesday. Okay, homework. And if it has a individual quiz, then you're going to take the quiz also. Quiz. And then we'll left with only one more section. That is 10.6. Solving radical equation. But we are going to do that in our next class. I'm too tired. Yeah. So that's all for today. Enjoy your 20 minutes. But does anybody have any question, comments, concern? Alana.
How does one do when they have like I and then like exponent is like -25? So I know we have to do percentage shorts, but
You have to turn into negative. Oh, sorry. You have to turn the negative power into a fraction, and then do all the math on the denominator, and then rationalize the denominator, like the one we did here.
yeah. So far we have like one question and answer that. Okay.
So in your homework, you have only one of them, I think.
Why is there like a I on the bottom?
Because when you convert the negative power to the denominator, I to the positive power of the denominator. And then 25, you break it into pieces. 24 and 1. Now I to the 24 and I to the 1 power. I to the 24 is divisible by 4. The answer is 1 for I to the 24. So you have 1 times I on the denominator, which is I. So the answer is 1 over I, but you cannot have I on the denominator.
So since 25, 24, that's it, the I there, right? To represent that there is a +1 in it, right?
1 times I, that is 24 times I. I to the 24 times, bye guys, see you on Thursday. I to the 24 and I to the 1. The I to the 24 becomes 1, real number 1.
No, isn't like I to 24 times, because that's what
Exactly.
I 24 times I, well, then I equal to I 25 then. Yeah, that's what I'm saying. That's what we have the I there for, right?
What do you
Because
mean?
look, it became 24. You gotta figure out why it became 24 for a reason. Put that in the equation.
Right,
That's what I'm getting at.
yeah.
Okay.
So anytime you have odd power, it becomes one I and everything else goes to the other I.
Are the fractions for like here, are they like? What's going on in the bottom?
Negative means you have fraction, right?
Yeah.
So I to the negative 25 means you have a fraction, I to the positive 25 on the denominator.
No, cause I see 1 times I, and then like at the bottom, it's I.
Result becomes 1 over I, right? The end results, 1 over I.
Oh, since you're trying to rationalize the,
You cannot have I on the
Denominator.
denominator.
yes, and trying to rationalize the denominator. Oh, there's, sorry, I thought you like, I thought at some point you were like, okay, so how do I phrase it? I thought in the top row it was 1 times I, and then in the bottom row it was I times I. That's what I was like, why you can't say
You
I?
get it after you rationalize. But before rationalizing, the answer for I to the negative 25 is 1 over I. The answer for I to the negative 25 is 1 over I. But you cannot accept that answer because I is on the denominator. So that's why the red one means you're multiplying top and bottom to rationalize the denominator.
I didn't know you were rationalizing. I thought you just had I's to time stuff.
No. We times I, but to rationalize. Mhm.